All right, I think we're going to go ahead and get started. Hello again, and thank you for joining us. I'm Jasmin Nevarez, Digital Content Coordinator here at Simulations Plus. Director of Business Development, Eric Jamois, will introduce our speaker for today. In this webinar, David Miller, Vice President of Cheminformatics, will show us some of the new features in APX.4. Just a few housekeeping items before we begin. We take your privacy rights seriously. By attending this event or participating in the Q&A session, you are allowing us to contact you for follow-up. You may ask questions via the questions panel on your dashboard at any time. If you need assistance, please use the hand raise icon. We'll address all the questions in the Q&A after the presentation. Go ahead, Eric.
Thank you, Jasmin. Good morning, good afternoon, and good evening to everyone. Thank you for joining us in this webinar featuring our most recent release of ADMET Predictor. We're going to focus on the new 10.4 release, which will be marketed as APX.4. There are some general enhancements to this release, which David will be covering in detail. And I'm also reminding all of our users that our MedChem Studio module remains free with any paid-for module. So if you have not done so already, make sure that you get your license. I don't want to steal the thunder from David, so without any further ado, it's my pleasure to introduce Dr. David Miller, Vice President of ADMET Cheminformatics R&D at Simulations Plus. David, the floor is yours.
Okay, thank you, Eric. Thank you, Jasmin. And again, welcome everyone to today's release webinar for ADMET Predictor version 10.4. All right, so here is an outline of the webinar today. As is now the custom, I will give a brief introduction to ADMET Predictor as a whole for the benefit of those who may be new to it. I'll then outline the new features that we've added for this version. And then hopefully, if there's time, I will briefly demonstrate some of those new features using the software. Okay, so the functionality of ADMET Predictor can roughly be divided into these four areas. Property prediction includes physicochemical properties like pKa, log D, solubilities, permeabilities, and so on. Substrate, inhibitor, and Km models for 10 key transporters. Metabolism includes substrate and inhibitor classification models, as well as quantitative kinetic models focused on CYPs, UGTs, and AOX. Toxicity includes endpoints such as Ames mutagenicity, hERG blocking, skin sensitivity, and several others. And finally, there are customizable risk scores that predict overall ADMET liability as a single number. The high throughput pharmacokinetics module provides mechanistic simulations similar to our GastroPlus software. It allows estimation of fraction absorbed and bioavailable, several important PK parameters, concentration versus time profiles, and the dose required to achieve a target user-specified plasma concentration at steady state. Our model building engine allows clients to build their own machine learning models using their data and our proprietary set of over 340 molecular and atomic descriptors. And finally, there are a number of useful cheminformatics features, including a recently introduced module called Artificial Intelligence-Driven Drug Design, or AIDD. There are features for organizing compounds by common scaffold, R group decomposition, match molecular pairs, and several others. And I'll come back to several of these areas in the remainder of the slides in the demo. Our property predictions are based on neural network models built using training data from collaborations, commercial databases, and literature. We start by generating our molecular and atomic descriptors, then build collections or ensembles of models where final predictions are based on the average of the individual predictions within the ensemble. This plot shows the performance predicted versus observed of our PKA model, which has been ranked as the #1 QSAR-based PKA model in a number of recent challenges. The user manual has these types of performance plots for all of our models. The pharmacokinetic predictions are different in that they're based not on QSAR models, but rather on mechanistic simulations. They make use of the ACAT model to describe transit through the GI tract and a compartmental model to describe distribution and elimination. The overall model is an only slightly simplified version of compartmental modeling using our GastroPlus software. The simulation setup for HTPK requires input parameters like compound solubility, permeability, and intrinsic clearance. These can be experimental values if you have them, or they can be predictions from ADMET Predictor or elsewhere. Running the simulation then involves integrating a system of time-dependent differential equations from which you can derive parameters like fraction absorbed and bioavailable, estimate CP time profiles, and so on. Okay, and then finally, I'll just briefly show some useful companion features that I won't have more time to talk about today. So you can perform an in-depth analysis of a compound's ionization microstates, predict log D or solubility as a function of pH. You can visualize the substructures having the most influence on a particular prediction, HERG in this case. And you can explore the BCS or DCS classification of compounds. And there are many other features. There are several options for deploying ADMET Predictor. The command line version runs on both Windows and Linux and has functionality for ADMET property prediction, pharmacokinetic simulation, and much more. The property prediction engine can be included as an optional module in GastroPlus to provide property estimates when experimental data is missing. We have both KNIME and Pipeline Pilot components. There's the interactive graphical desktop version that runs on Windows. And we recently introduced a REST API where predictions run on a dedicated server. And that makes it easier to integrate ADMET Predictor functionality into third-party software. Okay, so that was a very basic overview of ADMET Predictor as a whole. So now I will go over some of the new features that we've added in version 10.4. So a major new feature of this release is the ability to generate 3D conformers. The methodology is described in the user manual, but briefly, it integrates our implementation of the MMFF94S force field, which was developed at Merck. Macrocycles and other complex bridged ring systems are handled using distance geometry, and it does not make use of a predefined library of fragments. There are options to generate single or multiple conformers for controlling the level of energy minimization and for incorporating user-defined 3D templates. The new functionality is available both from the graphical interface, where you can visualize the conformers, and from the command line, which again runs under both Windows and Linux. One obvious benefit of this new functionality is that it simplifies the use of our existing ADMET models built using our 3D descriptors. One example being our 3D solubility model, which does outperform the analogous model that was built with 2D descriptors. And I'll come back to this during the demo portion. The ability to reproduce protein-bound crystal structures from the PDB was not a primary design goal of this new feature, but we did evaluate its performance using the option to generate a diverse set of conformers and guided by several published comparisons of commercial and open source tools. And we found that ADMET Predictor is competitive with other commercial software with similar mean and median RMSD values versus the PDB structures when using equivalent software settings. And those settings include the maximum number of generated conformers, the maximum energy difference among all conformers, and the minimum RMSD between conformer pairs. And I'll point those settings out during the demo. We are very much interested in receiving user evaluation and feedback, and as such are not requiring any additional license to use this functionality. It's simply included with the base program. At the recent Simulations Plus MIDD conference, my colleague Michael Lawless presented a case study that made use of the new 3D conformer functionality. The study was based on our recently introduced AIDD module. So AIDD is used to discover compounds simultaneously optimized across multiple target objectives that are chosen by the user. A new extension allows external applications, such as a docking tool, in this case, Autodoc Vena, to be used for computing the objectives. So Michael showed that using ADMET Predictor for 3D conformer generation, AIDD was able to discover several novel compounds with good predicted ADMET profiles and high docking scores against the base 1 enzyme. You can download the full presentation from our website. There are several directions we're considering for future work in the area of 3D. Of course, improvements to the conformer generation algorithms themselves, such as adding an option to use a fragment database and improving conformer sampling for macrocycles. Improvements to ADMET property prediction. This could involve developing new 3D descriptors or new modeling techniques altogether. New functionality for 3D virtual screening. For example, similarity screening based on 3D shape and features. The image here is from a prototype 3D shape matching tool that we've developed using our 3D conformer generator and based on maximizing overlap volumes. The two compounds are from the original publication on the ROX tool from OpenEye, where a new chemically dissimilar active compound was discovered purely on the basis of similar 3D shape, and where the binding mode of that new active was actually confirmed experimentally using X-ray crystallography. As future work, we might consider extending our prototype to combine both shape and electrostatics, taking advantage of our advanced descriptors for partial atomic charges. Okay, we've made several enhancements to the HTPK module, mostly driven by customer requests. Mouse has been added as a new preclinical species, and this was made possible by 4 new mouse-specific models: liver microsome clearance, hepatocyte clearance, fraction unbound in plasma, and blood-to-plasma ratio. The details on the data curation and statistics for those models are provided in the user manual. Cmin was added as a new result parameter. And for the dose optimization workflow, this is the Cmin at steady state. There is a new command line option to save a file with values used for each HTPK input parameter for each compound. So in HTPK, you can specify, for example, that an experimental solubility should be used if available, but that in the case of missing values, the ADMET Predictor model should be used as a fallback. So this new feature makes it easier to keep track of which input parameters were actually used in the simulation for each compound and each input: solubility, permeability, clearance, and so on. Based on customer feedback, we added command line support for specifying a fallback value for the clearance source, meaning, for example, microsomes versus hepatocytes. So you can now, for example, specify that the preferred value should be a measured liver microsome clearance. But if that data is missing, you should fall back to a measured hepatocyte clearance. That mixing and matching was not possible with the previous version. And then finally, the user interface allows just a subset of the result columns to be saved and displayed. So if you only want to see, say, predicted absorption and bioavailability, you can suppress all the other columns that you don't want to focus on. This is important for some of our customers who are sometimes running dozens of simulations using different combinations of input parameters. For an insightful description of the real-world use of HTPK, we would encourage you to check out this recent publication from Roche and the University of Vienna. It shows that when using in vitro inputs, particularly for clearance, HTPK is successful in providing useful estimates of important PK parameters like AUC at the discovery stage. It also shows that for early discovery, HTPK is a viable alternative to full-blown PBPK modeling with GastroPlus and is extremely fast. I will just add that Roche was interested in quantitative predictions of AUC being within 2 to 3-fold of the measured value. If the goal is simply to distinguish qualitatively poorly bioavailable compounds from better ones, then we believe that HTPK is viable even when using all predicted properties as the inputs. In other words, HTPK can be used purely in virtual screening. In any event, we encourage you to download and read this very insightful article from Roche. Our 11 Ames models have been rebuilt using new proprietary data obtained from the Ames QSAR International Challenge Project from the Japanese National Institute of Health Sciences. The data was examined and validated by Ames test experts, both from NIHS and academia. The expanded training sets have significantly enhanced the chemical coverage and reliability of the models without loss of performance. And this chart shows the sizes of the training sets in the new APX.4 versus X3. The actual performance statistics for all 11 models are provided in the user manual. I'll just mention that the average accuracy across our model test sets, not the training sets, but the external test sets, is over 81%, whereas interlaboratory reproducibility of Ames tests is estimated to be only around 85%. So the performance of our models is quite good. We have added new functionality to the REST API, which was first released in ADMET Predictor 10.3. So there is a new API method called run command that will simulate a command line run on the server using the standard ADMET Predictor command line argument syntax. But unlike a true command line run, there is no time-consuming reloading of ADMET models and no possibility of a license being unavailable. This adds functionality missing in the first release, such as predicting the predominant ionization microstate at a user-specified pH value. Also, full concentration versus time profiles can now be collected during HTPK simulations, and time points can be sampled to reduce the network bandwidth. I'll try to show examples of both of these features during the demo. And then finally, the service can now run on Linux as well as on Windows. In Predictor 10.3, we introduced a new artificial neural network model for predicting the most dominant tautomer among a set of candidates. For this release, the tautomer training set has been greatly extended using Tautobase and other literature sources. My illustrious colleague, Marvin Waldman, gave a nice presentation of this work at the last MIDD conference, and you can download that from our website. And as with the last version, no additional license is required to use this model. Okay, I'll just briefly go over a few of the other enhancements for this version. We've added a number of new command line workflows, several related to the new 3D functionality, like conformer generation, energy evaluation, minimization, and rigid alignment. There are also new workflows to select compounds from a file using a query and to add new query-based attributes to compounds from a file. Models can be built and deployed using pH-dependent ADMET properties or descriptors calculated at a user-specified pH value. So this would be relevant in the case that you want to build a user model or a risk model that uses a pH-dependent descriptor or ADMET property. So for example, log D or fraction ionized. Previously, a user running this new model would need to use the same user-defined pH value that was used when the model was built. And that is obviously problematic. With this new version, the software will automatically use the correct pH when evaluating the model. The user manual has thorough instructions for how to use this new functionality when building models. There is a new command line option for SD file input to preserve as much of the original SD records as possible in the SD output. For example, all explicit hydrogen atoms. This is particularly useful when using 3D structures as the input, where all hydrogen atoms may be very important. New modeling descriptors have been added. Most of these were added to support the improved model for tautomer standardization. And you can find full details on these in the manual. There is a new feature to add user-defined attributes based on equations that contain generic parameters that are mapped at runtime to either constants or numeric attributes. This makes it much easier to create equations that depend on user-defined data. And I will show an example of this during the demo. A related feature allows users to define their own transforms to modify spreadsheet columns very quickly and easily. We've also made it easier to combine spreadsheet columns in various ways, like taking the minimum, maximum, or average value from pairs of cells, as well as a merge option, where missing values from one column are replaced with values from a second one. And then finally, for those using the MedChem Studio module, the R group analyzer has improved handling of stereochemistry when defining the unique R group substituents. Okay, I've left out a few other enhancements that you can learn about in the README file and in the user manual. But for now, I am planning to stop the slides and do some software demo. But I believe we have one more poll. I don't think we had a poll at all, did we? But
Yes,
Jasmine, do we have one?
Yeah, we can launch both of them right now. Let me go ahead and do so. So the first one is, are you currently using the ADMET Predictor software? Oh, and I guess it's also showing the second one, which is, what are your primary interests in joining us today? Choose all that apply, and we'll give it a few more seconds for both polls. All right. And these are the results. So it looks like it's half and half of those of you who are and aren't using ADMET Predictor. And most of them seem to show interest in the HTPK module. All right, David, we can go ahead and get started with the demo. Thank you.
Very good. Thank you, Jasmine. Okay, so I'm going to start by launching the new ADMET Predictor 10.4. I understand that this is now available for download on ShareFile. You should have gotten an email about that. And I believe that for the first time, the Linux version is available on the same day as the Windows version. Okay, so I'm going to start by just briefly showing some of the new features related to 3D. So if I launch the main settings window for ADMET Predictor, there's a new 3D tab that has a number of options on it. The first section relates to the generation of multiple conformers per input compound. That is turned off by default for the user interface because the user interface only stores, at the moment, a single conformer per input structure. I'll come back to that topic in a couple of minutes. Energy minimization is turned on by default. There's a setting here where you can specify an external 3D viewer application. So we have not yet taken the time to develop our own. So if you want to launch, 3D structures from Predictor to visualize them, you would have to set one up here. We've experimented with several, both free and commercial. You should be able to use anything that can be invoked with the path to an SD file as a parameter. If you need to do special setup, like set an environment variable or something, you can write your own script and then put the path to the script here. I'm going to be at first using a free program called Avogadro for the visualization. Once the settings are attached or set, you can easily generate 3D structures. So I'm going to open up a small set, an SD file that has 1,000 FDA approved drugs in it. And of course, these structures are all 2D. So I'll quickly open that in the program, and then to generate 3D structures, there's a new toolbar button for that. So it's generating a single 3D conformer for each of the 1,000 compounds. It's pretty fast. You notice that the depictions in the window have not changed. They're still 2D, but the single stored 3D conformer is evidenced by the geometry column, which now shows 3D here. There's also an energy column. So these are the minimized energies via the MMFF94S force field. The appearance here is much as it would be had you opened up an SD file that already had 3D coordinates in it. If you want to visualize the 3D structure for a single compound, you would select it, and then provided that you have specified a viewing application, you can click a second toolbar button here that will launch that one structure that you can then see. You'll notice that all the hydrogen atoms are specified here, even though they're not displayed in the 2D depiction. So once you have the 3D structures, for example, if I were to export these compounds to an SD file, you see there's an option here where you can choose to export the 2D coordinates or the 3D coordinates. If I were to save the entire spreadsheet in the native ADMET Predictor format, which is called an HTPK file, that would save both the 2D structures and the 3D structures. So that if you open that file up, you would see the same view here with the geometry column and so on. If you generate ADMET properties, so if I launch the button to show the available ADMET properties, if you're starting with 3D structures, then you will see a box that has become enabled here. It says use 3D models. And if I click that box, then any predicted property for which we have both a 2D and a 3D version, ADMET Predictor will automatically run the 3D version of the model. So I mentioned solubility as one example where we have a separate 3D model. And there are several others. If you open up the model editor, that will show you a list of the models for which there is a separate 3D model. And then, of course, there's a lot more information about it in the user manual. I'll just point out that you can also develop your own models with ADMET Modeler that make use of 3D descriptors if you start with 3D structures as the input. All right, I'll just quickly generate the properties for these 1,000 compounds. All right, and then one of the last things I wanted to show for 3D, I think I mentioned that if you are interested in generating multiple conformers per input compound, then you will be using the command line version of ADMET Predictor as opposed to the user interface. But if you are interested in just visualizing the multiple conformers for a single compound, then we've made that pretty convenient to do directly from the user interface. So I'm going to just find a different compound really quick here. Somewhat larger one. This is a small macrocycle. So if I want to generate and visualize multiple conformers for just this one compound, I'm going to select it and then go back to the settings and enable the feature for multiple conformers. And I alluded to some of these options here, like maximum number of final conformers, the minimum RMSD between conformer pairs, and so on. These are all described in the user manual. And then I'm going to quickly switch the viewer to one that better handles the simultaneous display of multiple conformers. This is a free tool called Yasara. So once I've done that, I'll just regenerate the 3D structure for this one compound. I'll say selected only. And then conformers are generated. They're written to a temporary file. And then the viewer that I selected opens up that file so you can see all the conformers. They are aligned to one another, although for a flexible compound like this, it's a little bit hard to see that. So in the user interface, only one of those conformers was actually stored, and it was the lowest energy conformer. So now if I keep this compound selected and just directly launch the viewer, it will show that there's actually only one conformer stored inside ADMET Predictor. So again, if you're interested in generating multiple conformers per molecule, then you'll be using the command line version of Predictor, which allows you to create a giant SDF file, that has multiple conformers for lots of different input compounds. All right. I think the final two features we have related to 3D are for the situation where you open up file that already has 3D coordinates. So there are options to compute energies with the force field and to perform minimization. As I said, we are planning to expand the functionality around 3D, hopefully for the next version of the software. All right, I think that's all I wanted to say about 3D. I'm going to just take a slight departure here and talk about some of the new things we've done with the API. So I showed this in the last webinar for the last release. So again, I have a remote machine set up. And so this is remote desktop looking at that ADMET Predictor server machine. So I've installed ADMET Predictor 10.4 on that machine. And I've also installed the ADMET Predictor service, which comes as part of the ADMET Predictor install. This, of course, is a Windows machine, and there's a similar process for doing this on a Linux machine. So if I start the service on that machine, it's going to immediately read a configuration file that has information about, for example, which ADMET Predictor licenses should be checked out. Those get checked out immediately. What is the location or the path to the Flexera license server? What port should be used? Should the communication be encrypted? And so on. And I just wanted to reiterate that if multiple requests for properties are coming into the server at the same time, those requests get put into a queue and the jobs run one at a time. But as you'll see, that the jobs are generally very, very fast. Okay, so I'm going to close the remote machine, and then here on the client machine, I have to launch a client program to make requests to that server. So I have kind of a mock client application here that's meant to emulate tools like Live Design or D360. We have several customers using those, and they want to access ADMET Predictor functionality from those interfaces. So I think there's about 50 compounds here in this interface. There's a little settings page here where I have the IP address of the ADMET Predictor server, port, SSL information. And I'm going to check a box to actually save the HTTP requests and responses so that I can just quickly show them at the end. So there are APIs to request the lists of available properties to be predicted. And there are several categories of them. So for ADMET, this will show you, perhaps a very large list of available properties and descriptors. And this will depend on the licenses that you have. For me, it's a very big list. So I'm going to actually uncheck some of these, maybe select all the way up to solubility and just check those. There are two HTPK workflows. The simpler one is just running a single simulation at a fixed dose. There's about a dozen predicted properties, FA, FB, pharmacokinetic parameters, and so on. Similar set for the dose optimization workflow. So here the main prediction is the dose, which is required to achieve a user-specified plasma concentration at steady state. And there's maybe a dozen other parameters as well. I won't show this workflow, but this is for creating images. So you get an image of a structure with highlighted atoms indicating, for example, what are the predicted sites of 3A4 metabolism. So there's a set of properties related to metabolism, and then there's a separate set related to, a lot of them are based on, for example, our estimated partial atomic charges. And then finally, there's a workflow related to predicting metabolites, either from CYPs or from UGT. And here again, I'm going to deselect most of these and just select the 5 major CYPs, 1A2, 2C9, 19, 2D6, and 3A4. Okay. So one of the prediction APIs is to predict all of the requested ADMET properties. So here, basically the only parameter that you might specify is the pH value, and that would affect predictions such as log D. We also have a predicted solubility at a user specified pH. So here, when I click calculate, it's going to make a request to the server, and then very quickly, the predicted properties for these 50 compounds come back. It includes information about predictions that fall outside of the applicability domain. I'm showing those in red. There's also information about confidence values and uncertainty values for the predictions. And this client is not displaying those properties, but they are brought back. Something similar happens for the HTPK workflow. This is the one that just runs a single simulation at a fixed dose. There's quite a few more input parameters that you can provide here. I'm going to just leave them all at the defaults, but I want to show the new option for requesting concentration versus time profiles to be computed on the server and then brought back to the client. So this is a syntax that we borrowed from the command line. So here I put in 0.2, which indicates that I want the CP time data to be sampled at 20%. So 20% of the times and concentrations will be brought back just to limit the amount of bandwidth that's used. So with that, I think I can click run. Again, submits a request, and then almost immediately the results are brought back to the client. Again, predicted FA, FB, and PK parameters. The CP time data was also brought back, and it's been stored here. So I can just select some compounds and display those CP time curves here. It's not images that are brought back in this case. It's the actual times and concentrations as data. Just quickly, I don't think this has changed since the last release, but I'll just quickly show metabolite prediction. I'll do it for just a single compound. Here, the options are pretty much the same as what you would see in our MedChem Designer sketching software. And there's an option here to create an image of the metabolite tree. The image will be created on the server, and that image looks very much like what you would see in MedChem Designer when you predict metabolites. So if I say run here, it runs on the server. That image is now stored there, as well as an SDF file that contains the predicted metabolite structures. So I can pull either one of those back to the client. Now I'll just pull the image back. So this looks a lot like what you would see in MedChem Designer. And we have customers who are interested in storing images like this in their database. Okay, and then just lastly, quickly, I'll show the new feature for essentially simulating a command line run on the server. So here, I'll run one of the popular workflows, which is to predict the predominant ionization microstate at a user-specified pH value. So again, I'm just going to use one compound. It has the imidazole ring here, and I'm going to put in an acidic pH value where you would expect this to be protonated. So this is pretty straightforward if you are familiar with ADMET Predictor command line syntax. So I'm going to just put in the commands that I would typically use if I was actually running ADMET Predictor from the command line. So there's one argument to specify the pH value, which I'll just put in 5.0. There's a command to specify the special workflow that calculates ionization microstates and their relative populations. It's called the computational chemistry workflow. And then one final one to say, I only want the most dominant ionization microstate, not all of them. And that's kind of a cryptic notation here, -S and then a large number, I think greater than 50% will ensure that you only get one predicted microstate back. So if I click calculate, it sends the request to the server. And what I get back is a list of files that were created on the server. And it's the exact same set of files that you would get if you ran ADMET Predictor directly from the command line. So now I can retrieve one or both of those files from the server. And here it's an SD file. And if you're familiar with SD files, you can see that it has protonated one of the nitrogens from the imidazole ring. I think I'll close this now, but I'll just briefly show the saved set of HTTP requests and responses. This file was just created. So it has things like this inside of it. So this was the original request for what are the available ADMET properties to be calculated. So you get this gigantic list that has names of properties, data types, extensive tooltips, what license is required for it, and so on. For me, this is a very, very large list. I think I'm running out of time, so I'm just going to show the last one we did, which was the request for the command line run. So here, really simple request. So we're sending in just a smile string, and here are the command line arguments that we want to be run. And then, as I said, we get back a list of the files that were created on the server. So there's an error log file that always gets created, and then the result SDF file. And then there's basically a simple request to retrieve that file. So here's the file I want. It uses a job ID as well, and that's a way we make sure that there's no way that output files from one client would get mixed up with output files from a different client. Okay, so that's in a nutshell how the API works. Now I have a few minutes left. I'm just going to switch back to the predictor interface and just show one more feature that I alluded to in the slides, and that has to do with creating new equations, and you can think of them as columns in the spreadsheet that are based on equations, and the equations are making use of other columns in the spreadsheet. This is a generally useful feature, but we kind of designed it with the HTPK users in mind, because they are often bringing in a lot of data from the corporate database that they plan to use as inputs to the HTPK simulation. So, for example, in vitro experimental values of clearance or of solubility, for example. And they often have to manipulate that data before they can use it directly in HTPK. The units may not be exactly what HTPK expects, or they have to convert a liver microsome half-life into an intrinsic clearance, for an example. So they're often having to use the equation feature to create new columns in the spreadsheet. There is a feature already, it's data, add compound attributes. We have an equation option, and if I select this, it'll show me kind of a calculator view where I can construct an equation that makes use of existing columns. It's a little tedious to use that. You can save the equations to a file and reuse them, and that makes it a little easier. But that assumes that the names of the input columns are never going to change. And if they do change, then you would have to go back and modify the equations in those files before you could reuse them. So we were asked to try to simplify this workflow a bit. So one of the things we did was add a new option called template equation. So when I select that, it opens up a file, a single file called template equations that's part of the ADMET Predictor installation. And it has about these 7 equations are there in the default version. So I have not actually modified that file. Users can add whatever they want to this file. So every time you launch this feature, that file will be read. I'm going to select an equation here that's used to calculate a scale plasma clearance from an intrinsic clearance. So it uses the well-stirred model equation that's based on liver blood flow and fraction unbound in plasma and so on. This is a section of the file that it read, and it shows the syntax. It's a little difficult to interpret the first time you see it. It's similar to our previous syntax, but now it allows some of the parameters to become generic so that you don't have to know the names of the inputs ahead of time, but you can map them now at the point that you're trying to use this equation. So I have a parameter for body weight. So I don't have to hard code the body weight in the equation. I can just have it be a parameter, and I can just type 70, for a 70 kilogram human. And then for the other parameters like clearance, if you have something from your database, you could either search for it in the list of all the columns you have here, or you can just start typing it if you know some of the name. So for me, all I have are the predicted ADMET properties. So I would just start typing, SIP HLM. It'll autocomplete like that. That's our model for HLM clearance. We have an FUP prediction and an RBP prediction. So it's pretty fast to be able to set this up. You change the name of the column and say okay and okay, and then you've added a new column, I think more easily than you would if you had to go through the entire equation dialog and create it from scratch. If that file, that same file, template equations, has any equations that use only one parameter, like a simple transform, like a log or inverse or some other kind of transform, then there's another workflow that you can use that's also very simple, where you can kind of choose the target column. Like say, I want to take the log of this value. I would right click this column, say insert column, transform, and then the list of all the simple transform equations that are from that file will appear here automatically. So it's a simple way for users to create their own transforms and then quickly access them from the user interface. So if I click this, it'll create a new column for me called log. So again, it's fully extensible. We have customers who have all kinds of things that they want to do, and this makes it pretty easy for them to do whatever they like and have a lot of control over this. Okay, I'm looking at the time. I think we have maybe 7 minutes left, so I think it's a pretty good time for me to just stop. And I don't know if we have another poll question, but I'm going to turn it back over to Eric and Jasmin.
Thank you, David. Really nice stuff in this new release. We have a couple questions that have come up, and one of them has to do with the transaction of structures. So, I think that mainly maybe for attendees who are not users of ADMET Predictor yet, wondering if everything is performed locally or on your machine, or if there is a transaction between a client and a server or some external instance. So that may be something to clarify for the software itself and maybe also for the API.
Yeah, that's a good question. So, we only introduced the API in the last release of ADMET Predictor 10.3. It was only about, 8 months ago, I think. Prior to that, the use of ADMET Predictor was, there was no reaching out to any external server. So you would install Predictor locally at your company, and all the predictions are performed locally. Nothing ever leaves, your company or your machine, other than to check out a license. That's the one exception to that, is that you would reach out to some Flexera license server that would check out a license. Other than that, the data never left the machine. With the API, now there's a new paradigm where you can choose to install Predictor on a server machine, and then the client would send, structures out to that server machine, and then the predictions would come back to the client machine. But, even in that scenario, the ADMET Predictor server is still stored at your company. It's still something that you control. And there are also options, even though it's local to your network, you can still choose to encrypt the communication back and forth. So there's kind of two different paradigms. If you're using the API, then there is network communication, but it's all at your site.
Okay, great. Thanks for clarifying, David.
Yeah.
Another question has to do with the maximum size of compounds that you can run for ADMET Predictor. I recall in previous releases having a limit of 256 heavy atoms. Is that still in play?
That strikes me as familiar. I think we have a couple of different limits. I think just to open and visualize structures inside the interface, I believe the limit is 1,000 atoms. But in order to compute ADMET properties, I believe you may be right that it's 256. That sounds right. And then I think there's another limit, if I'm not mistaken, on the number of ionizable groups in a compound. And I believe that's set to somewhere on the order of 20. Could be a little higher. That's a very unusual compound, but just to put that out there, I do believe that that's another limit.
Yeah. And I think, I mean, the other parameter for sure is the scope of the models, and if you had something too large, even though for one particular model, it wouldn't really necessarily, the number of heavy atoms may not be really the sort of limiting aspect of performing the prediction.
Yeah, it may look very different than what we have in our training data.
Yeah, exactly.
Yeah,
So
but of course, companies can also develop their own models using ADMET Modeler, and perhaps they do have a lot of training data that is, that has larger compounds in it, and that should work. But I do believe, yeah, there is a limit of 250 atoms.
Okay. And there's yet another question, which I think relates to the 3D conformer generation, is whether you can use a essentially a set of smiles, like a file containing smile strings, and then process that in batch mode and output 3D coordinates to an SD. So do you need to have a 2D SD as a starting point to generate 3D coordinates, or can you?
No, you don't. No. So for input, so that would be something done with the command line version.
Yep.
And the way that works is, yeah, you have an input structure file with presumably 2D. Well, actually, for smiles, you have nothing. you have no coordinates. Yeah. You could have a smiles file, SD file with 2D coordinates, SD file with 3D coordinates. It doesn't matter. The output is going to be an SD file with 3D coordinates. But yes, you can start with a smiles file.
Okay. Great. Thank you. And maybe one last one which came to mind. So when you said that during the HTPK, you can use experimental data, and if there's missing values, it'll trigger, well, it will use an in silico model for solubility, for instance. Do you need a special license to PhysChem properties in order to quote unquote fill that blank, or does that run normally as part of the HTPK simulation?
That's a good question. I'm 100% sure, I want to say, Eric, you may know this better than me, but if you have the HTPK module, the license, then you are essentially entitled to all the predicted properties that serve as inputs to HTPK: solubility, clearance, permeability, log D, FUP, and so on. So you don't need separate licenses for example, the PCB module in order to get solubility inputs for HTPK. If you have the HTPK license, that's enough. So it's really covering, both the PCB and the metabolism.
Yep.
Yeah.
No,
that's how it works.
The case. Yeah, that's 100% sure thing, and which really is the entire philosophy, that there is no cross-module dependencies within ADMET Predictor. So there's never a situation where you need one module to use the other. So that remains true in all circumstances. All right, I think we've reached the top of the hour. I would like to thank everyone involved, in particular you, David, for providing all this great content. And if anyone has questions that were not answered in the course of this session, we encourage you to reach out to us, and we'll be happy to work with you to get them answered.
And with that, Eric, I'd also like everybody to invite them to learn more about ADMET Predictor on our website. And you can also find us on LinkedIn, Twitter, and Facebook. This webinar has been recorded for playback and will be available on our website and YouTube channel. This concludes our webinar for today. Thank you, everybody.
Thank you.
Thank you all.
Thank you all.
Have a good one.
Bye-bye.